Hello, welcome to the class of Advanced Stats and Econometrics. In today's lecture, we are going to discuss Logit and Probit models. So sometimes dependent variables are not taking continuous variable but categorical. In those cases, we cannot apply linear regression model because of the several reasons. I am going to discuss it, and in that case, we will use Logit Probit models. Qualitative response regression models. Regression models involving nominal scale dependent variables are among a broader class of models known as qualitative response regression models. Here we will consider the simplest of such models, the binary or dichotomous or dummy dependent variable regression models. Problem with linear probability model. The linear probability model LPM uses the OLS method to determine the probability of an outcome. Problems. First is the LPM assumes that the probability of the outcome moves linearly with the value of the explanatory variable, no matter how small or large value is. The probability value must lie between 0 and 1. Yet there is no guarantee that the estimated probability values from the LPM will lie within these limits. The usual assumption that the error term is normally distributed cannot hold when the dependent variable takes only values 0 and 1, since it follows the binomial distribution. The error term in the LPM is heteroscedastic, making the traditional significance test suspect. Logit model. If the outcome decision depend on the unobservable utility index, then this index can be expressed as I subscript I star is equal to B times Xi plus Ui. If the person's utility index I exceeds the threshold level I star, the dichotomous variable Y is equal to 1, and if not, then Y is equal to 0. Y is equal to yi is equal to I if I subscript I star is greater than 0, and if it is less than 0, then this yi will take value 0. Therefore, probability that yi is equal to 1 is equal to probability that I star is greater than or equal to 0, or probability that b times xi plus ui is greater than 0 or equal to 0. So this is the probability, same as probability that ui is greater than equal to negative b times xi. So if the probability is symmetric around 0, then probability that ui is greater than equal to negative bxi, this is equal to probability that ui is less than or equal to bxi. Therefore, probability pi is probability that yi is equal to 1. This is equal to probability that ui is less than or equal to b times xi. ui is assumed to follow a cumulative probability distribution, where probability that y is equal to 1 is given as pi is equal to 1 over 1 plus e raised to the power negative z, where zi is equal to bxi plus ui. Py is equal to 0 is given as 1 minus pi, this is equal to 1 minus 1 upon, this is 1 upon 1 plus e raised to the power zi. So, Logit model, the ratio of true probability is the odd ratio in favor of the outcome. So, Pi upon 1 minus Pi is equal to 1 plus e raised to the power zi plus 1 plus e raised to the power negative zi, or it is e raised to the power zi. The log of the odd ratio, logit, is given as capital Li is equal to ln Pi upon 1 minus pi, this is equal to zi, this is equal to b times xi plus ui. Notice that if we take the log of the odd ratio, then we get the same model as the linear model, linear probability model, or the classical model in which you have the b times xi plus ui. This is how it is related with the classical model. Characteristic of Logit models. as Pi goes from 0 to 1, Li goes from negative infinity to infinity. Although Li is linear in Xi, the probabilities themselves are not. If Li is positive, when the value of explanatory variable increases, the odds of the outcome increases. If it is negative, the odds of the outcome decrease. The interpretation of the Logit model is as follows. Each slope coefficient shows how the log of the odd in favor of the outcome changes as the value of x variable changes by a unit. Once the coefficient of the Logit model are estimated, we can easily compute the probabilities of the outcome. In the LPM, the slope coefficient measures the marginal effect of a unit change in the explanatory variable on the probability of the outcome, holding other variables constant. In the Logit model, the marginal effect of a unit change in the explanatory variable not only depends on the coefficient of that variable but also on the level of probability from which the change is measured. The latter depend on the value of all the explanatory variables in the model. So if we have a different model, Probit model, in the Probit model, the error terms follows a normal distribution. So in the Logit model, it was following a logistic distribution. Given the assumption of the normality, the probability that I star I is less than or equal to I subscript I can be computed as the standard normal cumulative distribution function CDF, as Pi is equal to probability that y is equal to 1 given x. This is same as probability that capital I star I subscript I is less than or equal to I subscript I. This is equal to probability Zi is less than equal to Bxi. This is equal to Fb times Xi. F is standard normal CDF. It can be written as F of I is 1 over under square root 2 pi integration over negative infinity to bxi e raised to the power negative z square to z square upon 2 dz. If we multiply the Probit coefficient by about 1.81, or this is roughly equal to pi upon square root of 3, we will get approximately the Logit coefficient. The marginal effect is given by the coefficient of the variable multiplied by the nature of the normal density function evaluated for the x values for that individual. Logit versus Probit. Logit and Probit model generally gives similar results. The main difference between two models is that the logistic distribution has slightly fatter tail. The conditional probability Pi approaches 0 or 1 at a slower rate in Logit than in Probit. This follows directly from the difference in the distribution, in which logistic distribution has fatter tails. So probability is higher for fatter tails. In practice, there is no compelling reason to choose one over other, which means you can use either Logit or Probit. There is no compelling reason that why you are using Logit model or why you are only considering Probit model. But in practice, you get similar results. You have just given another option. So both these generally give similar result. Many researchers choose Logit over Probit because of its comparatively mathematical simplicity. This is just one reason why Logit is preferred over Probit. Later on, other models also developed from it, like Tobit, that is Tobin's Probit, or Hackett, that is just the Hickman's correction. So uh, basically these are the basic model Logit and Probit, and uh, Tobit and Hackett are basically modification of the model. And the reference for all this is a book titled Econometrics by Example, second edition. Publisher is Palgrave Macmillan and author is Damodar Gujarati. That's it for today's class. Thanks.